By the hammer of Thor!
Adding and subtracting rational expressions are just like adding and subtracting any other type of fraction. In order to do so, I first need a common denominator. So looking at these two, in order to get a common denominator, I'm going to need to find the missing factors of the first denominator that are present in the second, and vice versa, the missing factors of the first denominator that are not present in the second. So looking at this, these are actually very easy because these are relatively prime, but 3x plus 4 is an entire factor which is not present in the first fraction, so I'm going to need to multiply on by a factor of 3x plus 4. And the reason I multiply both the numerator and denominator is because 3x plus 4 divided by 3x plus 4 is just a special form of 1. These two factors would cancel out, it would make this number 1. So by multiplying on by just 1, I'm not changing what this expression says, so its value has remained the same. But it's going to get me into a form that's going to enable me to combine these fractions. Similarly, in the second one, I'm going to multiply by x minus 3 over x minus 3 so that I can get it into that common denominator form. Next, notice that I've rewritten this after having performed that multiplication, so I'll have x minus 3 times 3x plus 4 and x minus 3 times 3x plus 4. So you can see that the denominators of these two fractions have become the same, which is why I multiplied on by those specific numbers. And in the numerator, I'm just performing that multiplication of the x. I'm writing it in the standard form. Now notice that the next thing I would do is, since these are in both over a common denominator, I can express them as a single fraction over that denominator.
Sweet grandmother's spatula!
Now notice that I haven't really done anything to, or no real mathematical insight has come from rewriting it this way. However, this is the form that's going to be most useful for me for doing my mathematics. So what most mathematicians do when doing this process is that they skip this second step and they go right from this multiplication to a single fraction over that common denominator that I've identified with my numerator written out in the numerator. Once I have it written in this way, I'm going to do my distribution. I'm going to distribute my x into my first binomial and my -2 into my second binomial, which will give me this expression. So again, that x into this first binomial will give me the 3x squared plus 4, and I'm distributing the entire value -2, so -2 into x, give me -2x, and -2 into -3, give me a +6. Once I have this, I'm going to clean it up a little bit by combining my like terms. So I'll get an expression that looks like this by combining these two similar terms here. And the last thing I'm going to do before I finish this question is check to see if I can factor the numerator. Because if I'm able to factor the numerator, I might be able to cancel one of those factors with one of the factors of the denominator. In this particular example, my numerator is a prime term, so I'm not going to be able to factor it. So this is actually my final answer.
Uncle Jonathan's corncob pipe!
So let's look at an example where I might have to factor at the end. Here's example 2. Now, before I do anything, notice that I have 3 completely different denominators. But rather than multiply my first denominator by both the second and the third, I observe that my last denominator looks like it can factor. In fact, when I factor it, I end up with a plus 2 times a minus 3, which happen to be both factors that are present in the first ones. So really, the only factor that's missing from the first denominator is the a minus 3. So I'm going to multiply that first fraction on by a minus 3 over a minus 3. The only factor that's really missing from the second denominator is the a plus 2. And conveniently, in that third denominator, the a plus 2 and the a minus 3 are already present. So I don't need to multiply on by anything, because notice that now my 3 denominators are all the same. And my goal is to get them all over the same denominator. So that'll be my denominator for the rest of the question. A plus 2 times a minus 3. So now, one other thing I'm going to do that's going to be a time-saving tip for whenever you're doing rational expressions is, rather than rewrite a times a minus 3 plus 2 times a plus 2 minus 3a plus 1 in the numerator, I'm going to do those distributions all at the same time. So I'm going to distribute my a into my first set of terms. That'll give me my first terms in the next question, so a squared minus 3. I'm also going to distribute my second one, which is positive 2, into the second binomial. That'll give me my second set of terms, which will be plus 2a plus 4. And then, and this is something that a lot of students tend to leave out, notice that, oops, notice that on my last term, there's an operation of subtraction here. So I'm going to distribute that subtraction to both of the terms in the numerator. And that's going to give me a minus a, 3a, minus 1. So that's where all my terms are going to come from. So you can do that distribution as you rewrite the question. Then I'll combine my like terms, which will give me this expression. And this is where I'm going to check to factor. So I'm going to check to factor my numerator here. I'm going to look for terms which multiply to positive 3 and add to negative 4. So negative 1 and negative 1 and negative 3 will do that for me. So I'll have an a minus 1 times a minus 3. And this is where factoring helped me, because now I have a set of like factors in my numerator and denominator. I'll be able to cancel my a minus 3 in the numerator with my a minus 3 in the denominator. And my final simplified result will be a minus 1 divided by a plus 2. And I will box that as my final answer. So to recap, what we've done here is that whenever you have a series of rational expressions, the first thing I would do is factor my denominators to see what factors I really need to multiply on by. So my largest denominator here, a plus 2 and a minus 3, had all of the factors of the other denominators already present. So all I needed to multiply on by in the first one was its missing factor, a minus 3, a plus 2 for the second one, and both of those factors were already present in the third. So now they'll all be over a common denominator. And then I rewrote my fraction over that common denominator after having done that distribution, combined my like terms, factored, and simplified.
You stay classy.